Prove that n squared minus 1 is divisible by 8 if n is an odd integer. So if we let n be equal to 2m minus 1 for m being a integer, that ensures that n will be odd. If we take m is 1, for example, we're going to get 2 minus 1, which is 1. If we take m is 2, we're going to have 4 minus 1, which is 3, which is odd, and so on. So therefore, n squared minus 1, so instead of n, we're now going to write 2m minus 1 all squared minus 1. We expand that, so it's 4n squared minus 4m plus 1. Also taking away 1, the 1s will cancel, and we end up with 4m squared minus 4m. Now, if m is 1, 4 times 1 squared minus 4 times 1 is actually equal to 0, which is divisible by 8, because and then if m is 2, we got 4 times 2 squared minus 4 times 2, which is 8. 16 minus 8 gives us 8, which is also divisible by 8. And let's try m is equal to 3. Same idea. 4 times 3 squared, 9 times 4 is 36, minus 12 will give us 24, which is divisible by 8. But we can't keep on doing that. So we'll have to do a proof by induction. The first part we've already done up here. It's true for a particular value n is equal to 1, 2, or 3. So what we're going to do is we're going to assume true that it's for m is equal to k, e.g. 4k squared minus 4k, which is our expression, will be equal to 8 times a, where a is an integer. That assumes that this is divisible by 8, so we assumed it's true. And therefore 4k squared will be 8a plus 4k, and we'll perhaps use this in the next part. So we'll now prove true for m is equal to k plus 1. So our expression will be 4 times k plus 1 all squared minus 4 times k plus 1. So expanding that, we're going to get 4k squared plus 2k plus 1 minus 4k minus 4. Taking that 4 in the bracket, we're going to get 4k squared plus 8k plus 4 minus 4k minus 4. This 4 and this 4 will cancel. And then 8k minus 4k will give us 4k. So we get 4k squared plus 4k. But here we've got that 4k squared is 8a plus 4k. So we'll replace it from the assumption. So 8k plus 4k is using the assumption. And therefore we're going to have the 8a plus 8k. And 8 will come out as a common factor. So therefore this is also divisible by 8. So we need to write a conclusion now. So if the result is true for a particular value, for m is equal to 1, and if it's true for m is equal to k, which we assumed, then it was also true for m is equal to mk plus 1, and therefore the result is true for all m belonging to z by the principle of mathematical induction. Okay, and therefore the original statement n squared minus 1 is divisible by 8 if n is an odd number is true. Okay, so there's been a video to show you how to show an expression when n is an odd number, it will be divisible by 8. I hope you've understood, and I thank you very much for watching, and maybe you could consider subscribing to my channel. And in the link of this video you will find a link to my website, where you'll find thousands of videos which will help you with A-level maths and A-level further maths. I thank you very much for watching.